And here we have some word problems. Starting with 15, a string. Let me draw this string. Measuring 2x squared minus 3x inches. So the whole thing measures 2x squared minus 3x. It's cut into two pieces. How tragic. Two pieces. Very tragic. If one of the pieces measures x squared inches, what does the other piece measure? So we know what the whole thing measures. It measures 2x squared minus 3x. It's cut into two pieces. One of the pieces measures x squared, and the other one we just don't know. But we do know that if we were to add the two pieces together, we would get the total, which is 2x squared minus 3x. So let's just solve for the question mark. And to do that, we're just going to have to subtract x squared from both sides of the equation. So question mark will be equal to 2x squared minus x squared is just x squared. And the minus 3x just comes down, and this is what the other piece measures. So just x squared minus 3x. So the answer is B. Now question 16. Same type of question. A string measuring x squared minus 3x plus 4, so that is again the whole thing, is split into two pieces. Poor string. If one of the pieces measures 2x plus 1 feet, what does the other piece measure? So if we add up the two pieces, 2x plus 1 plus the question mark, which we don't know, which is the measure of the second piece, we would get the total of x squared minus 3x plus 4. So what can we do to solve for this? We can essentially just subtract 2x plus 1 from both sides of the equation. Minus 2x minus 1. Why did I do this? Well, if I were to distribute the minus 1 over here, another way to see it is that every time we have parentheses and a minus outside, we're just essentially combining it with the additive inverse. So we switch the signals. Right? So over here we get to completely rid of the 2x plus 1. We bring down the question mark. So we have x squared minus 3x. We're subtracting 2x. So we get minus 5x. And 4 minus 1 is just 3. So this is our answer right here.